So we've got an AND gate here with A coming in, A and B. Here I've got an OR gate with B coming in, and C is also coming in to this OR gate, so I've got this coming out. So I'll finish everything on the input side first. So here, this is a C coming in here. Here I've got B coming in, and it's another AND gate. So here I've got B and C. Now I know what my inputs are here. So my output of this AND gate is going to be B, C and B plus C. So this is my output of this one. And finally, I've got an OR gate here with AB going in and this expression going in. So my final expression for Q is going to be AB or the final expression coming out of the circuit, so our output, is equal to this: A and B, or B and C, and B or C. So that's the expression that we now need to simplify. So first of all, I'm going to expand out my brackets. And this thing we can tidy up already because we know that B and B is just going to be equal to B. And similarly here, C and C is going to be equal to C. And we also know that BC or BC is just going to be equal to BC. So you can leave the expression like this, or you can write it with the B terms taken out, because both of these circuits are actually just as simple as each other. Here you've got two AND gates and one OR gate, and here you've got one OR gate, and you've got one AND gate. So here you've got fewer gates, but actually if you remember back to when I showed you on your chip, you've actually got just one type of gate. So if you look in terms of how many chips these would require, even though this one has more gates than this one, for this one you would require two different chips, and for this one you'd also require two different chips. In this example, I'm going to start with a Boolean expression, and I'm going to draw out what this means in terms of a circuit, a logic circuit, combinational. So we always, in this case, we've got A and B, so we've only got two inputs. So we always start with our A and B. Now, I'll just start with this term. So we know that we've got a not A. Now, how do we get a not A? Well, we have to first introduce a not gate. So remember what your circuit symbols look like. So this gives us A coming in, and here I get not A coming out. But the not A has to be ANDed with B. So B is going to come up here, and I need a AND gate that looks like this. And B feeds in here, not A feeds in here. So coming out, I get not A and B. What about this term? Because at some point I need another OR gate. So I'm going to have an OR gate here, because this is going to be ORed, but I have to deal with this term here. So what happens here? Well, I have an A or B. So I need to tap off from A. Let's see, I'll draw that over here. So let's just jump over that one. And then I also need to tap off from B. So here I can have another OR gate where this is B here. So B is coming all the way through. So I've got B as one of my inputs, and then I've got A as one of my other inputs. So here coming out, I've got B and A, and here that's my input. So out of here I've now got my not A and B, or because it's an OR gate, coming from here. Doesn't matter which way around I write those. To draw a truth table for this expression, I need to start with my inputs in the correct order. And then I need to look at all of these steps. So I can just break these down. So you already know for my A or B, I end up with this, not A, not A and B. So I'm now looking at these. So when they're and, and then finally for here, I'm now taking this column or this column. So these two here. So in this case, you can use the truth table to see immediately this column is actually the same as this one. So you already know just from looking at this that this is going to be equivalent to A plus B, A or B. And we can also calculate that to make sure using Boolean algebra. So let's just make sure. Start by taking out my brackets. So this is the same. You can see that I've got a B in common here. You know that anything or 1 is just going to give you 1. Anything and 1 is just going to be itself. So you can see that this matches what we had with the truth table. This is just one more extra example that I'll show you where I'll simplify using Boolean algebra, and then I'll also check the answer using a truth table. So this is a really good example of in mathematics where you can use lots of different methods to get to the same answer. So one of the rules that is really useful and will allow you to solve this really quickly is this one that I showed you earlier, where A plus A times anything, in this case it's just a B, but this can be anything, is always equal to A. Now we can employ this immediately because you can see here you've got A plus AC, so you know that's the same expression, right? So this is going to be equal to A, but you've also got B plus BA, which is the same expression but with B's, so this is going to be equal to B. So I can see that this is equal to A and this is equal to B, so my final expression is going to be A plus B. So that's a very quick way of employing the rule. If you're not sure though, you might have been tempted, if you couldn't see that straight away, instead maybe thinking, okay, well, what I'll do first is rearrange this, because then I've got all my A terms here, my B terms there, and maybe you thought, okay, well, what I can do here is maybe take the A out because that's common and I get 1 plus C. And here I can take the B out and I get A plus 1. And 1 or C is always going to be equal to 1, so I end up with A times 1. And here I get the same, A or 1 is always going to be 1, so I get B1. And A and 1 is always going to be A, and B and 1 is always going to be B. So here you get exactly the same solution, but you've gone through it in a slightly different method. You've gone through it from scratch. You might also be tempted to just group all of the A values because there are a lot of them. And if you pull the A out of all of these, you end up with this. And if you have 1 or anything, that's always going to give you 1. That was one of the rules that we introduced as well. So again, slightly different method, but exactly the same answer.